Sukuriam konceptą, mastom, aptariam, nesutariam, atsipalaiduojam ir vėl galvojam, pasiekiam bendrą sprendimą. Kas toliau? Kuriam prototipą, eksperimentuojam, testuojam, sugriaunam, pradedam iš naujo, pažiūrime viską iš kito kampo. O kas po to? Darbas nesustoja. Gerinam dizainą, optimizuojam kodą, ieškom, tyriam, sekam procesą, sutvarkom likusias klaidas. Pailsim. Ar tai viskas? Paleidžiam produktą, reaguojam į žaidėjus, pritaikom kritiką. Taip mes sukuriam gerą žaidimą. Atšvenčiam, pasiemam atostogų, įsikvepiam ir sukuriam naują konceptą. Siekim tobulumo kartu, kurkim žaidimus, kurie augina, įkvepia ir ugdo. Tuto Tunes.
As we cross over the 10th anniversary of our presence here in Lithuania and reflect on what that last decade has brought, it's absolutely incredible. The Windows editor was developed here, and the mobile runtime and the mobile support for Unity was done here.
Aras, well, I think one of the first employees of Unity, he joined Unity and he was working, and I think he decided to go back home.
And then we moved back. I moved back to Kaunas, and someone else moved back to Vilnius, and that's why we have two offices. The very first office that we got in Kaunas, that was only for 2 people. Very first people were very, I would say, self-motivated and didn't need much guidance or much sort of hand-holding.
We have access to a lot of great talent here in Lithuania, a lot of motivation, I would say.
That's amazing about the people in Lithuania is how they're able to see a really hard problem, not be scared of it. They have the courage to actually tackle that.
They're working in architectural changes of Unity and preparing Unity for the next 10 years. So they play a very key role here.
You've got to be mission and vision driven. And at Unity, we believe the world's a better place with more creators in it.
Okay, you can hear me? 1, 2, 3. 1, 2, connection check. Okay, so we can start. Awesome. Hi, everyone. My name's Stefan. I am a developer and a product owner in MS1's studio at Wargaming, which you might heard about already. And I'm here to talk about the game playability system in Unreal. Why would you want to use it and how you would want to use it? So the title might have been a little bit confusing because about the characters. I will mostly talk about the basics of the system and various reasons why you might consider using it or not using it for your project. Now, 1 second. So my experience with Unreal started from version 4.3, back when I was developing a game called Insomnia: The Ark, which you can find on Steam now. And later I joined Wargaming to work on World of Tanks Blitz, and then to do some prototyping with Unreal. And back in 2019, I found myself asking questions about the ability system and whether it is indeed a system that can be used for a production-ready project, for something that could be a live game. Back there in Unreal Fest in Prague, I was wandering around asking developers, and I met Matt Edmonds from Splash Damage, who did a presentation on the ability system, which actually hit the spot for me. It answered all of my questions. So I want to spread the word and share what I found with you, mixed with my own experience of using this system. And if you are new to the system or you heard about it and you, as I wasn't sure whether this is a good thing to commit to when starting a new project, because well, using a framework, frankly, is a huge commitment, so you have to consider all the options. So we'll be talking about that. First of all, let's talk about what the system is. The system is basically a framework for game designers and programmers to collaborate, creating different gameplay-related actions. And I'm specifically avoiding a use of the word ability here because when we talk about abilities, we're imagining some mobile games like League of Legends or Dota, or maybe RPGs like World of Warcraft, Diablo, whatever, with all those crazy whirlwinds with fire and fireballs raining from the sky. And the ability system can do all that, no problem, but it is also more than that. Some more mundane actions can be considered an ability in terms of this system. For example, like shooting a gun, crouching, reloading a gun, or even in multiplayer games, things like spraying a picture on the wall or like playing some taunt animation. Those things can be done with the ability system as well. And in terms of why, is because the ability system is a great thing when it comes to multiplayer readiness. It has a lot of issues of a multiplayer game already thought about and a lot of situations handled. I will talk about this a little bit later, but this is indeed something you can use for any type of a multiplayer game. It is well distributed and easy to work on with big teams. It spreads out assets pretty evenly. As you know, like this is basically Unreal's approach, right? But we'll talk about this later. The blueprints can be a little bit tedious to work with when it comes to version control systems because they are binary assets. So if you want to like merge them, if you want different people to work with them, there will be concerns. Like merging them and looking for diffs is pretty like it's harder than your average code, right? So you have to consider all the options, and this, well, it does help a little bit. Now, when it comes to questions about whether it is useful for C++ or blueprints, the answer is it is for both. So it does require some basic C++ code to set up, but it is a boilerplate code. So if you only want to use blueprints, that's fine. You need to copy paste that code, initialize some of the components in the system in C++. You can't avoid this, but after you do this, you can forget about the C++ later if you want to. But if you want to build a nice architecture and everything kind of spread out through your code and through various systems, the C++ layer will definitely be helpful to you. So let's cover the integral parts of the system, what it is about. Those are main concepts the system introduces. Some of them might be new to you, but in any case, let's get going. So the ability system itself manages everything the system is about inside the single actor. So it's not like a system that you add to a scene and it handles everything. It is an actor component, so it works with everything on per actor basis. Yeah, that's basically it. So you generally use your pawn for it, but I've seen mentions in the internet and by some of the developers of Unreal Engine itself. It could be used in player state as well, but there are tricks and issues with it, mind you. Just a little bit of a heads up there. So gameplay ability. It is, as talked before, a piece of game logic, some action or sequence of actions, which has a low-level base C++ class you can derive from, build on top of it, and then create high-level asset, which is basically a U asset as anything else, which can be used, reused, and whatnot. And as mentioned before, any action can be an ability. It's not just some RPG stuff. It actually helps to solve a lot of more like simple actions you might want to see in your game. Gameplay effect is, well, it is an effect in RPG terms, but still a little bit more. It is a data asset that contains something that needs to happen. And things that can happen is attributes might be changed or gameplay tags might be applied. This is actually the most of the things this thing is about. It can be a time-based effect or instant effect or an infinite effect. Instant effects are something like damage. So it gets applied, it changes the health, and then it disappears completely, leaving the changes it made. Or time-based or infinite effects that are only applying those changes while they are present actively on the target. They can stack as, you know, the stacking mechanic from a lot of RPGs you might have played. There's various settings on how this work, what are the limits and whatnot. But one of the most important things, and you might not have thought about this firsthand, but they are able to grant or remove abilities. It sounds like a weird thing when you first come in contact with the system, but actually it's useful for a lot of things. Like you want to do a combo attack and each new hit of the button does a little bit different effect, like a different swing of the sword. Or maybe you want to have one good example is actually for reusability of the stuff you make. As if you want to have a cannon that does a knockback on enemies, you can have this knockback implemented as a separate gameplay ability. So you hit a target, you apply an effect, which grants and activates the ability of knockback. So when it happens, the target kind of knockbacks itself. And you can use this for any other effect and any other ability in your game, which is pretty useful. For actual attributes and tags, let's see what they do. So gameplay tags are used to handle interactions between different abilities and effects, and they sort of identify effects. They give it this little note, which it does, and using those notes, you can set up different things on how abilities and effects work with each other. It can be cooldowns, for example. So the cooldown is an effect too in terms of this ability. When you cast an ability, it applies a cooldown effect, which is a time-based effect with a tag, and why this tag is present on your hero, character, whatever, the ability cannot activate again. It can be used to grant immunities to some effect. For example, you have one effect with attack damage and another effect that prevents effects with attack damage to be applied. Or if you want to make, I don't know, a silence spell which prevents other spells from being used. So you set up your gameplay abilities that are spells with certain tags. You have a spell tag there, and you have a gameplay effect that has a silent tag there, and you set up this interaction so one thing blocks the other. We'll cover this and a little bit in depth when I actually show you how this works in the engine. And yeah, one other thing it can be used for is application of a tag can be used to activate an ability, or as mentioned, block its activation completely. Attribute set is a set of your generic parameters, and this is one of the things that has to be done in C++ layer. So the descriptions of your attributes, which is mostly boilerplate, you just declare variables with all those meta tags on them. but it is something you have to write in C++, and then ability system hooks it up for all the blueprints, for all the ability-related stuff to use in engine. It supports replication, of course, as we said about the multiplayer game readiness. It can be modified by effects, and this is basically the only way how they can be multiplied. So by default, effects can have different operations like add to these attributes, multiply them, override them, but there is also an ability to write your own calculation class for the gameplay effect. So if you, for example, have like multiple health bars, right? You have a shield bar, an armor bar, and health bar, and you want the damage you receive to be distributed evenly. First of all, it comes into shield, then it splits between health and armor, whatever, right? Some crazy stuff you want to do. This thing helps you do that. And there's also post-gameplay effect execute in the attribute set class that can help you do some other, like after the gameplay effect has executed, you may do some clamping or some propagating of some values to other attributes if needed be. So this is how it can be set up. Gameplay cues are mostly bells and whistles of the ability system. They are used to display all the things that are happening. For example, gameplay cues can be tied to gameplay effect, and once your character gets healed or gets a buff, there is a neat VFX around them and the sound is playing. They can be static, they can be actors inside the level, so it defines whether are stateful or stateless. Or you don't have to tie them to effects. For example, there's no effect when you just hit a wall with a gun, right? But there should be a little particle there, so you can just spawn them manually using a gameplay cue manager. Gameplay events are, well, your general messages that you can use to set up some interactions. For example, there is an ability that is activated when the certain animation is played, when the certain event from the animation is sent, or when you get damage, you have to, display a shield. There's a passive ability, so it would activate when the gameplay event, is received on the hero, and that's how you can set this up. So basically, just messages as in any other system. And gameplay task is a little bit low-level thing. It is a block of functionality that is asynchronous that can be used inside gameplay abilities when you are writing scripts. Some examples of it could be just playing an animation and waiting for a certain event or certain effect, or just for the animation to finish, or do a target detection for your ability. For example, this is an aura, and you have to track everything that gets in and gets out. This is something gameplay task can help you with. The default tasks also include something like synchronization between client and server or spawning object. And there is a little bit of magic there, but we won't cover it here. So talking about the C++ basic stuff you'll need to create, I won't paste all the boilerplate code here because there could be quite a lot. Some might argue there are hundreds of this code you need to copy paste, but I think not so many. First of all, you'll have to create ability system component instance, and it is basically done the same way as any other component, and attribute sets basically the same way as any other subobject. They are initialized, added to your actor you want to use them on, and then you create this tsub class of variable, which should be your property, by the way, to just expose this variable to engine, where you can actually set up an ability asset into this. And then with one line, you just grant this ability to an actor. And with this very line, you can also bind it to certain input, or if you don't want to do that, you can activate ability with, there's a method called activate ability by tag, which might we use later. So how the basic script would work, this is like the very basic stuff. First of all, node by node commit ability is something that commits the cost and the cooldown. So after this node, it is considered to be committed, right? So we casted this ability, cooldown is applied, cost is applied, which is energy cost or whatever cost. It is actually a gameplay effect too. It basically checks whether this effect can be applied, whether you have enough of certain attribute for this effect to be applied, and applies it after the ability is cast. Then we launch montage. This is, let's pretend this is a heal ability, right? So we launch some healing animation. Character does some whoosh, some crazy stuff. And at a certain point, this animation sends an event, at which point we apply gameplay effect to ourselves. When the animation is finished or interrupted, we close the ability and everything fine. You might notice the get ability level node here. And this, I'll tell you where it comes from. It comes from Paragon, because the ability system was initially developed for Paragon game, and they have, like as a mobile game, they have leveled up abilities. So if you want to have different levels for your abilities and effects, this is actually built in. If you don't want to, this is fine. Just leave this field blank. Nothing bad will happen. Just everything will be level 1. Nobody will notice. So, how the parameters of the gameplay ability looks. You can notice here a certain amount of tags, as I told previously. So those are used to set up those interactions. I won't cover each of them separately, but you might assume there's some requirements on this ability can only activate when certain tags are present on yourself or on your target, or it can't activate when certain tags are present on yourself or on your target, or when it's running, other abilities with certain tags can be activated. So stuff like that, pretty useful, pretty messed up, but pretty useful. There's advanced functionality for network synchronization. So those could be the things, whether this ability replicates or not. So if you launch this on the server, whether it does the same thing on the client, whether it replicates its flow on the client or not. How it is instant, it could be instanced per actor, which means the instance of the ability is always there, whether it is running or not, if the actor has it. It can be instance per execution, so there's no instance until the ability is running and it's killed when it finishes. Or there can be just one ability fits all. It is just one ability, and every actor that has it uses that instance. Execution policy covers one of the fanciest things you might have in a multiplayer game, which is prediction. If you want some things to be predicted on the client when you launch this ability and send the launch request to server, you might want to have it local predicted. Otherwise, you can launch it only on server or only on client. This is actually up to you, whatever you may want to do. Gameplay effects for cost and cooldown mostly covered. Just a gameplay effect with either attribute modifier or a tag, and that's basically covered. That's most of the default parameters it has. For the gameplay effect, however, it's a little bit trickier because well, there's a lot of cover, so let's start with the basics. This effect is supposed to be a periodic heal effect. So it gets applied once every some seconds, 1.5 seconds in this case. It applies healing to the target based off the maximum HP of the caster. So this you might have seen this in games like Genshin Impact if you played it. There's various scalings from different attributes. You can base the damage of the attribute you have, of health, defense, whatever. And this is basically a nice way to do it. So what happens here? It is a time-based effect, so the duration policy is set to has duration. Other things, as I mentioned, could be an instant effect or an infinite effect. So how do we define duration here? So if we cover other part for a second and leave only scalable float and the little text box there, this is actually how we set up this parameter. But there's also a nice thing called curve tables. Now, curve tables are can be useful for your game designers on your team because, as I said previously, ability system splits everything in those various assets. We already see it, right? There's ability asset, there's a cooldown effect asset, cost effect asset, there's this heal effect asset. If you want a projectile to be spawned, it will be a separate asset as well, like a bunch of different assets, right? There'll be multiple effects for one ability. And your game designers would generally want to have all them in the same table to see all of them in the same space because it's just more comfortable for them to balance it. So there's curve tables. I'll jump to this previous slide in a second. That's how they look, right? They can't be created in the engine. They can only be exported from CSV or maybe JSON and, well, generally whatever you find a converter for. this is the collection of all the parameters your ability might need. So the first column here is the names of parameters, and other columns are basically parameter by level. So if you don't have levels in your game, it's just the one column for names, one column for parameters, and that's it. So how we use it in configuration of the gameplay effect. So the scalable float is actually the basic way to determine the value, and all the values used here can be calculated different ways: the duration, the period, how periods work, how much attributes are changed. Those things can be configured in multiple ways. Scalable float is the easiest of them because it only takes one value. Here we set a link to the curve table CT heal 1. It is this curve table I showed you. We select the actual parameter that we take from this table. The preview thing is just for cosmetics. It's just a preview. It does not affect anything. And the text box actually becomes the modifier, the multiplier for it. If we don't set up curve table here, it becomes the actual value that is used. But when the curve table is set up, it is a multiplier. So for us, it's 1 because we just want to take the value from the table. And yeah, that's it. For attributes, we want to do a little bit something a little bit trickier. So we modify health, of course, because we want to deal damage. So it is just additive operation for health attribute. Now, how much do we want to change it? We actually base this off attribute. So we select the value from the curve table, divided by 100, which means this health per tick thing here becomes a percentage. And we multiply our max health, which is, you can see here, attribute to capture. This thing is what this calculation will be based upon. So you take your max health, you multiply it by some percentage, and then you add the resulting value to your health, which effectively results in the heal that scales with your max health. There is even a snapshot thing here, which to you RPG fans might be familiar. This is something it defines when are we taking the value of the attribute we scale from. So for example, if your character is buffed at the moment the ability is cast and the effect is created, and it snapshots, it's just snapshots the attribute at this point, and for the whole duration it remembers it. If it does not snapshot, then when the buff fades, the new effects that are applied will use the updated value, which is lower. So this is some intricacies there that you might need. And there is also a period, which means how, basically, while this effect is active, each period it applies all the modifiers we have set up here. So as you see here, it is effect with a duration of 5 seconds, and yeah, those things are in seconds when the duration is concerned. It's each 1.5 seconds, 1.5, 1.5. Each 1.5 seconds, it heals you 10% of max HP. Since we apply this effect to ourselves, it basically heals us from our max HP. But if we apply this effect to someone else, it will take the max health of the source actor, which cast the ability for the scaling, and it will modify the base health of the target. So with this out of the way, back to the gameplay tags. So this is how it looks in gameplay effect configuration. Mostly the same thing. So asset tags are, as I said, identifiers. So this is not something that gets applied to someone. It's just what this effect is identified by. Granted tags are tags that are applied on a hero. So when we're checking this ability can run because we have this tag, those are what handle it. And there's also ongoing tag requirements. For example, until some requirement is met, this effect can't run. It will still be on the target. It will still spend some time, but it won't be active. It won't. Its modifiers will not run. And well, a bunch of other stuff to set up more of those intricate connections between effects and abilities. So, as I said, this all started from me asking questions about whether I should or should not use this for the project I was working on. And the first thing, when you start working with the gameplay ability system, the first thing you notice is you go to the Unreal's plugins section. You find ability system there, and it is marked as unsupported. There's like big caps lock unsupported notice there. So this kind of rings a bell, right? So you probably would not want an unsupported plugin to be used as a base for your next game. And this will be explained in a second. Next thing is, it is too complicated. There's a steep learning curve, and you have to learn a lot before you can use it effectively. And can this complicated system, which is like this bulky, actually be a stable solution for what you're trying to achieve? Because when you just try it, it seems like it's buggy and it does not do what you want to. But yeah, there are concerns. And like the most popular question, this is it caused some funny discussions in our team back when we were thinking about it. Like, why don't we write our own? Right? Should be easy. Gameplay ability this, effect that, should be fine, right? But there is some intricacies. So what we learned by working with the gameplay ability system. So the learning curve is really steep. And before you handle it, before you actually know what you're doing, which could be pretty hard because the documentation is, well, not where you want it to be. I mean, I will link a couple of good sources in this presentation, but the default Epic's documentation is pretty dry. It just documents stuff. There is no best practices from developers. There is a action RPG example for Unreal 4, and I've heard there is also a new example called Ancient Temple something for Unreal 5, which I frankly haven't checked out, but feel free to do and see. Maybe it has some new interesting info there. But there's a bunch of community documentation that can help you to kickstart yourself with this system, and you'll have to come up with a couple of your own best practices yourself. But once you do, it is worth it. It is hard to keep track of all the interactions with tags, so I advertise them enough. Now to the bad part. So when you set up those tags, set up this ability should be interrupted by this tag, and this effect should apply this tag. There's actually no way to track this inside the engine. There's no way to see this link inside the engine. So what you have to do when you're working with it, you have to instruct your game designers to keep a good track of all these things that you want to do, because later on you make a couple of abilities, couple of those interactions, and they're fine, but then questions will arise like, did we actually want to do this? Or is this a bug that it works like this currently? Or how should it be? How did we set this up back then? It's good to have this documented, so you have the place, the source of all that information, and you can sync your own project with this documentation from time to time, because it's easy to get lost here. Then again, lots of files. Like I told that it is something that helps you spread out the development and encounter less conflicts, because, well, there is certain issues with using locks in version control systems. If you're using SVN, is fine, but your developers will probably want to use Git. And with Git, there are plugins, but they actually hurt more than they help if you want to use locks. So at least from our experience, maybe there are some new plugins they haven't heard about, but still, there are some issues, and spreading those things out can help you lose less time fixing conflicts later. But if that's something that concerns you, yeah, there will be a lot of files just for one single ability. And yeah, we actually introduced the curve table, so another type of file to fix some of those issues for game designers, so they don't have to find required parameter in 3 different effects. So another thing is communication between gameplay ability system and other things is one way, and it is defined by ability system. So one good example could be if you want to have your gameplay effects affect the speed. So if you want like speed up effect, right, speed up ability or something, then what you would want to do is you would like to create an attribute for the walk speed, for example, mess with it with the ability system, apply some effects, buff it, debuff it, slow it down, speed it up. And then when this attribute is changed, you propagate the changes to the character movement component or whatever other movement component you use, and this becomes like this one-way interaction. So it is now driven by ability system. You should not attempt to change this by any other means other than firing a gameplay effect that changes this in ability system, because otherwise, well, you'll just end up with a messed architecture. So for things that ability system interacts with, they all have to use ability system to some extent. For example, if you need to have some environmental effects, some damaging, I don't know, traps, they will have to at least create gameplay events or gameplay effects and send them to actors that step on them, if not outright have their own ability systems attached to them, which can be mitigated by just having one ability system for some actor in the level that just handles all of those things, environmental hazards, but this is something that might scare you off. And another thing, it is event driven. There's a lot of events firing for ability start, certain state start, cooldown finish, whatever. But if you want to do, if you want to check for the current state of the system, might be tricky. So for example, for cooldown, it's actually okay. So you can check the timing on the certain gameplay effect with a certain tag if you know it. But if you want to see in which state the ability system is in and which gameplay task is currently running, you might be in for a disappointment. So it's good to have track of all the events and cache everything you need, because getting to the current actual state and checking it might not be possible in all cases. So back to the concerns we had previously and concerns I had personally regarding this system. Here goes. So the unsupported plugin. It is marked as unsupported, but this history is a little bit complicated. It was made for a Paragon game that is closed, but now there is another little game by Epic called Fortnite, which is live on mobile and PC and whatnot, and it uses the ability system pretty extensively. So you might think that the system that is used that widely can be actually suitable for a production solution. So other developers are using it, Epics are using it, there's nothing keeping you from using it. The unsupported thing comes from the developers not being sure they can spend enough resources on actually supporting the documentation, supporting the community when working with it. And our collective effort here can help us all, because the more we go to Answer Hub and post questions about the ability system, the more we do presentations like this, actually, the more people notice the system, the more people want to use it, which makes Epic consider that this system is worth exploring later on. As I mentioned, it is already present in Unreal Engine 5, mostly in this very state that I'm describing here to you. And there are even some changes done to it from time to time, so we can do it. We can show the developers that this is actually the framework that we all want to use. It seems too complicated. Yes, indeed. And as I said, until you grasp it, it might sound a little bit unstable or a little bit too bulky, but there was a lot of effort put to it by very experienced developers who knew what they were doing. And the learning curve is definitely worth it, because if you want to write your own ability system, you'll end up solving all those issues yourself, plus a lot of issues you might even never thought that there existed. So specifically the multiplayer part, and we'll get to this right away. So I've advertised this enough already. What the ability system does in terms of networking. Okay, of course, it activates the abilities remotely. Nothing new. It replicates attributes. Well, anything does it. It has some internal magic to it that does this a little bit more effective than just your common replication. So it groups things up specifically for the gameplay queue applications, because if you do this ability system way, as we call it, there might be a lot of different effects and a lot of stuff to replicate. So it groups it up nicely, and well, at least it helps you to optimize those things. But the most important thing, like the cherry on the top, is the prediction and validation and land compensation. And those are things that you will definitely encounter if you build a multiplayer-ready game. Now, you know, our server and our client are actually two different states of the game. There is a certain time that has to pass before the message is sent from client to server and before it is received. So they are in constantly desynchronized state. And we do a lot of effort to synchronize it. And there are some tricks like prediction, where we try to predict some things on the client before they actually happen in the server because of our input and, well, but generally how things move on the server. But there's also issues with it. So let's see this easy example of a reloading ability. So to give user feedback just outright when he presses the button, so he doesn't have to wait until this goes to the server and then goes back with a response. We want to just give feedback instantly, because this feedback for dynamic games can do, like, it can do a lot. It can, if you do not solve this, it might hurt sometimes your understandability really bad. So if you want to do the prediction, you start reloading, right? You check all the prerequisites on the client. It's fine. You have enough ammo. You're not stunned. You're not killed. So you put the disable shooting flag somewhere so you don't shoot anymore. You start the animation, and animation is running. At some point, you might even spawn the separate actor for the magazine to lie somewhere on the ground, just because it's fancy. And at some point in the animation, you change the amount of ammo in the magazine and in your backpack. Do those changes to the values, apply gameplay effects, change some attributes. And what if we did all that and then server reports to us, then actually, you know what, you were stunned by that before you actually did this and then killed, and now your client is in an incorrect state. So generally what we need to do is we need to roll back all those changes. And if we start solving those problems by ourselves, it can be a little bit messy, believe me. So what we do is, with the ability system, it offers the stuff called prediction key. And if you're not doing this C++, if you're only doing this in blueprints, it mostly works by itself. Mostly. I'll cover this in a second. So what it does, the prediction window is just blue part here on the graph, right? It is the part that we try to predict on the client. And when it starts, the prediction key is created and sent to the server. And when we do stuff on the client, we record this within the prediction key. And everything that is ability system related, changes to attributes, gameplay effects applied, gameplay cues launched, and gameplay tasks launched, they are all recorded there, ready for rollback when needed. The only thing that is not tracked here, as I mentioned, if we spawn a separate actor, they are not tracked here, but there are useful events to hook up to when you do this thing. So it still provides you something you can use for things that are outside ability system, because ability system doesn't know whether you spawned an actor or not, or did some other thing that is not a gameplay effect or gameplay ability or gameplay task or gameplay whatever. And yeah, the prediction key actually does regular things with the server. It keeps track of the predictive actions, and it basically saves you a lot of headache when you want to use prediction in your game. So to sum this up, though complicated, this ability system provides a lot of options and safety. It helps you handle the ugliest client-server interactions that are just come out of the box, which is a huge help. And it lets you actually focus on making a game rather than making an engine, which is like a pretty fine thing by itself, right? If you want to do the next big ability system for Unreal, you can go for it if that's your goal. But if your goal is to make the game, you want to focus on the gameplay and all the interesting fancy abilities and balance in your game, and not spend too much building your own thing when it was actually invented already. So another thing is it is statistically makes development faster and support of the created functionality easier. And this is basically, these are not my words. These are words of Matt Edmonds I passed to you, and he's a person who did his own ability system in a different engine, did his own ability system in Unreal, used the gameplay ability system, and in his presentation, I'll link it here, he has this all summed up in hours, like how much he spent doing this, and that. And yeah, this is actually better. This helps you create abilities faster, and it helps you spend less time actually supporting them. So this is how it goes. For the sources for this presentation, I of course, and yeah, sorry for the links, but it is actually easily Googleable. So Matt Edmonds talk in Unreal Fest Europe 2019. It is public. You can go there and watch it on YouTube. He covers some of the moments I just told you in more details, but generally gives you this very information. There is a game playability system documentation on a GitHub of user called Tranek, which like it was a huge help for me when I was educating myself in ways of the ability system, and it might actually help you. He also has a gas shooter project in his GitHub, which is a good way to see some of the best practices to use the gameplay ability system. It is a really good example along with what Epic provides. There's also a very old and a little bit ugly documentation, gameplay abilities, and you, which can give you a little bit of a kickstart, but it is a little bit outdated, so take it with a grain of salt. But it is one of the like easily found resources in the internet. And more recent resources, there's Varix's article in GitHub for the gameplay ability system in Unreal Engine 5, and he's the guy who used gameplay ability system inside the player state actor for the multiplayer games. And he covers a couple of tricks that you need to do if you want to do that. And judging by some words of developers in the internet, if your game has respawns, like if your character like dies and then respawns later, this is probably the way you want to go. He also has another article, or maybe some more articles about the Unreal system, gameplay ability system in Unreal 5 that cover more in-depth optimization for the networking and other things. And apart from that, there's actually a bunch of Unreal 5 tutorials on YouTube you can find. So this should get you going with the ability system. Let me, before we get to questions, let me just talk about one more thing. Now, you might have heard from our general director Thane that there's an MS1 studio, which is now in Minsk, which is known for developing the World of Tanks Blitz game I worked on, and MS1 actually one of the first tanks that you get in the World of Tanks Blitz game. And like we're in cool new studio that is now in Vilnius. We have a couple of offices here. And you probably, if you've seen the Thane's presentation, you probably saw this slide, but I just included it here for bragging, because first and the last picture in it are people who are our colleagues who are playtesting the prototype of the game I've been working on, which is one of those two. One of two unannounced action shooter projects that are currently in the works on Unreal using gameplay ability system. Some of them are GeoIP. So if this sounds like fun to you, as I said, a couple of offices in Vilnius. We're actually looking for a new talent here. So might as well check it out. And well, thank you for all your attention. I can answer questions if you have them right now. Actually, don't know where to listen to questions, but I guess Ricardus, can you help me with that? Mm-hmm. Yeah, so in any case, I am still here on Discord. So if you have any questions after this presentation, you can find me on Wargaming channel there, or basically any other channel. Ping me, Servalat in Discord, and I can help you with maybe any questions you have regarding the ability system, or maybe some other parts of Unreal. Okay, thanks. I guess there is no questions, so thanks for your attention once again.